power series. And the ones that we've got here are all called Maclaurin series. You all know that. We had it in our notes yesterday. You know they're Maclaurin series because these are just X's. So I'm going to do 3 more of these just for practice. And it's the same question for every one. Radius of convergence and interval of convergence. That's what we're going to find. So I'll start with the first one, this one here. I think last time we agreed, or at least I agreed for you, that I can miss out one of my lines of working. And so I'm going to try and continue that today. So it's going to be the limit as n tends to infinity of that. In other words, we're setting up the ratio test. And this is the line that we're starting on now. The top guy has n plus 1s everywhere. And that's to the power of 8, by the way. And then instead of drawing a big bracket in the second guy, I'm just going to turn the second guy upside down. We all comfortable with that line and not having big ugly fraction over big ugly fraction, then turning it up, right? I think we've reached the point where we can cope with that and it's not too weird. Okay, let's go hunting for things that can cancel and things that can simplify. Would you agree the 2 to the n plus 1 and the 2 to the n cancel out? I thought that was right. And if we do that, there's going to be a 2 left over in the bottom. And the x to the n and the x to the n plus 1 cancel out, and we'd get an x in the top. Are we comfortable with that? Right. The next one I'm going to write down a little bit more work. Okay, that's kind of where we are right now. Great. We've got an x left, a 2 left, and this fella here is going to be 1. I know it's going to be 1, but I want to try and prove that it's going to be 1 because proof is more important than conclusion. Now, I could do L'Hopital on that. I'm not going to because I'd have to do L'Hopital about 7 or 8 times before I got to prove it was 1. Okay. I could FOIL this out, couldn't I? And divide the top and bottom by n to the 8 and prove that it was 1. Would you agree foiling n plus 1 to the 8 would probably not be a good idea, because of the work it involved. So I'm going to do this, which can happen quite a lot. Are you comfortable with the n to the 8 over the n plus 1 to the 8 being combined into a single fraction? Are you comfortable with that? Now, would you agree that n over n plus 1 is 1? And you could prove that by L'Hopital or divide top and bottom by n. So wouldn't this be 1 to the power of 8? And isn't 1 to the power of 8 1? Would you agree that's a much more efficient way of just proving it's 1? Especially if that power ends up being 100. Can you imagine n to the 100 when you go this road? Right. So since this is 1, we have that. So far, so good. Now, according to the ratio test, the answer to the limit has to be less than 1 if something's going to converge. But if we want to find the radius and the interval of convergence, don't we have to take this and rewrite it as the absolute value of x less than, right? So if the absolute value of x over 2 is less than 1, what will the absolute value of x be less than? Basically, do something to both sides. Agreed? Yes, I do. So we now have one of our 2 answers. Isn't the radius convergence 2? Now the interval of convergence, at least right now, is going to contain -2 to 2. But to finish this, don't we have to check the boundaries, right? The endpoints. So I have to check whether or not, for these 2 specific values of x, this converges. Right, I'm going to put -2 in for x. And I think I should be able to squeeze it in here. -2 to the n over n to the 8, 2 to the n. Pull that out as a -1 to the n, a 2 to the n over n over 8, 2 to the n, and that becomes this fella. Okay, do you recognize who this guy is? Does he converge? Does this series converge? Yeah. Alternating series, agreed? So I'm just going to say converge, but you could go and improve the rest. Now, if you plug n equals 2 in, you get 2 to the n to the 8, 2 to the n, which becomes 1 over n to the 8. Would you agree that's a power series, a p series? P equals 8, and that also converges. So when you put that package together, the interval of convergence uses the two outside numbers. And so the final correct answer is square bracket -2, 2. Now, when you're doing your WebAssign, the endpoints are important. If you write this down, you might get lucky 1 in 3 turns where that happens to be the right answer. But you have to test the endpoints, don't you? Because one or both may also work, in which case you put a square bracket if you can use them. That's a pretty standard type of power series question. You comfortable with the process? Good. So just 2 more to do just to finish this list off, then we'll talk about Taylor series. So the second one is 3 to the n squared x to the n. Okay. We'll do the ratio test. 3 to the n plus 1, n plus 1 squared, x to the n plus 1, all over 3 to the n squared, x to the n. Actually, that one was pretty easy to write, wasn't it? We didn't even need to turn things upside down. So, anybody to cancel? Can you tell me some things that might simplify here? Anything that can cancel.
The 3 to the n and x to the n.
Right, and when that cancels, what's left and where does it go?
There will be a 3 on the top, and then for the x, there'd be an x on the top.
And we'll leave that other guy for a minute. So what we've got is n plus 1 squared over n squared, and basically a 3x, agreed? Okay, couldn't we just FOIL that one out, make it n squared plus 2n plus 1? Couldn't we do a L'Hopital on it or divide total by n squared? Would you agree it's going to be 1 eventually? Right, so for speed, I'm just going right by that. And that means we have this fella. Okay, now it's going to converge if it's less than 1, which in turn gives me that. So I have a radius of convergence of 1/3. Can you imagine this is the x-axis and right there is 0. And at this side and at this side, you have 1/3 and you have -1/3. And so as long as x is kind of in this window, right, this little range, that's where the interval of convergence lies. But isn't the radius of convergence just the distance from the center to the outsides? So if you're wondering what the R is, isn't it basically just saying from 0 plus or minus, right, either side? Now, we still have to check the endpoint. So we have -1/3, and we're going to check +1/3. If you do -1/3 in here, you get 3 to the n squared, -1/3 to the n. That's going to be 3 to the n squared, -1 to the n, over 3 to the n, and that becomes -1 to the n squared. Agreed? The 3 to the n's cancel out. Converge or diverge?
That diverges.
Right. Correct. Why, Eric?
It's just going to go to infinite.
Could use the divergence test on it if you wanted to be more formal. So that's a big D for divergence. Now, if we go the other way, we get 3 to the n squared times 1/3 to the n. That's 3 to the n squared over 3 to the n. Technically, it's 1 to the n over 3 to the n, but 1 to the n is just 1, so I didn't write it. And that cancels out. And would you agree that that is also a diverger? So in this second situation, wasn't the interval of convergence still the same as it was before? In other words, neither of the two endpoints make it. Do you see the endpoint sometimes can be used, the endpoint sometimes don't get used, right? Depends on the situation. Comfortable with that one? Okay. Last one of this type, and then we'll move on. So I'm going to do this fella. I'm going to do a limit as n tends to infinity of n plus 1 squared x to the n plus 1 over n plus 1 factorial. Then you turn it upside down with n's. Okay. X to the n plus 1 cancels out the x to the n, you get an x left over. N and n plus 1 factorial also cancel. What do you get if an n factorial cancels an n plus 1 factorial? What gets left, and is it in the top or the bottom?
N plus 1 in the bottom.
Great. Do you see in this question, we now have an n plus 1 cancelling. A little bit different. And now we are left with, oh, by the way, there's an x there. We're now left with an n plus 1 over an n squared x. Forget about the x for a minute. What is the limit of n plus 1 over n squared going to get you? This one you could do L'Hopital or divide top and bottom by n. What does this get you?
0.
Yeah. And won't 0 times x, just overkill here, isn't that 0? Regardless of what the x is, agreed? Which means that isn't it guaranteed to be less than 1? And so we now have the radius and the interval of convergence. Okay, what is the radius of convergence in a situation where every value of x works?
Infinity.
And what's the interval of convergence then when every single value of x works?
-infinity to infinity.
I like those questions because don't they involve a lot less work? Because you don't need to check the endpoints. Now, I haven't done this one. I'm not going to do one because I know we did one yesterday. But can you imagine we did the limit of the thing and the limit ended up being infinite, right? You remember we did one yesterday with that happened. So we had a series and the limit is infinite. Well, doesn't that mean it's never going to work? But there was one exception to that, right? So when it's never going to happen, the radius convergence is 0. What is the interval of convergence? What's the only value of x a power series is guaranteed to work for, no matter what the power series? You got it, a big fat 0. So you could do an interval notation like that, which is kind of weird, but isn't that an interval? that starts at 0 and finishes at 0. So technically, isn't that a weird way of saying just 0? Right. To me, saying that kind of makes more sense, but whatever. The next group is of power series. It's the only one that we've got, are called Taylor series, and they look like this. Let's find one right off the bat. There's one. This is going to be question 9. And it looks like this format. Okay. So these are called Taylor series. And to be specific, it's a Taylor series centered at, well, A equals 2 is a common way of saying that. You could say centered at X equals 2 and it has the same meaning. Now, if you are centered at A equals 0, aren't you just a Maclaurin series? So Maclaurin series is just a special case. Now, a lot of the math that we're going to do here is going to be very, very similar to Maclaurin series. So I'm going to do ratio test. So it's going to be the limit as n tends to infinity. Right. To the power of n plus 1 over n plus 1 to the 4 plus 1. Right. And then you turn them upside down. And you get that. It's a little bit uglier, a little bit messier, but it's essentially the same process, right? I'm now going to see if there's anything I can cancel. Right away, I think the only obvious cancelling would be these two, agreed? And just like all the others, have you noticed that they tend to be one guy that's left over? And later on, you'll see situations where that might not be the case, but typically it's one. What on earth has she got? Look, she's eating cans now. You dumb dog. We've got a full-time job, try to teach and watch her. So where was I? Yeah, you cancel these and you're left with a little x minus 2 on the top. So I'll stick him here. And then I'm going to take this guy and this guy. This is the problem, right? Agreed? What will this become as n goes infinite? You should be able to gut feeling, you should get a feel for what's that going to be?
1.
It's going to be 1, isn't it? Do you know the proving of it's going to be the hard part, right? Knowing it's 1, you know, you do enough of them, you kind of know it's going to be 1, right? What you don't have is the ability to prove it. So I could do L'Hopital in this. Can you trust me after 4 shots it would work and I'd get 1? I can, and I'm going to do n to the 4. I'm just going to adapt it a little bit. I'm going to divide the top and bottom by n to the 4. So here goes. N to the 4 gets you 1. N to the 4 to that guy gets you 1 over n to the 4. Put a big bracket around it to separate it from this term. Now you take this guy and you get 1 over n to the 4. If you have n to the 4 and n plus 1 to the 4, can't you bring them inside? And if you bring them inside, you will get 1 plus 1 over n to the 4. Are you happy about what I did there, or would you like to see it in a bigger form? N plus 1 to the power of 4 is being divided by n to the 4, and it gets you this guy. Are you comfortable with that to there? Do you want to see it? I got a nod that I'm comfortable. Anybody not so comfortable? We're good with that? Okay, if you brute force that, don't you get 1 plus 0, 1 to the 4 plus 0, 1 over 1 gets you 1. So you get 1. All I'm trying to do is prove it, right? So you've done the ratio test and the limit is equal to this. For it to converge, doesn't that have to be true? Right, that's pretty much what we did before. So I now know that the radius of convergence is 1. The interval of convergence is the values of x that you can use. Now, when it was the absolute value of x less than 1, wasn't it easy? -1 to 1. You see, it's now a little bit trickier. So if you have an absolute value less than 1, it can be turned into that. Are you comfortable with that? That the absolute value means that this guy in the middle is somewhere between 1 and -1.
Yeah.
If you then add 2 to everybody, does it make sense that the interval of convergence now is not symmetric? Isn't it from 1 to 3, right? It's slightly off-centered. And that's our I guy. And guess what? Just like we did in every other question, don't we now test the endpoints to see if they work? So the 2 endpoints that I'm interested in checking are x equals 1, and the other one is at x equals 3. If you check x equals 1, you go up here. So what do you get? You get 1 take away 2 to the n over n to the 4 plus 1. That becomes -1 to the n over n to the 4 plus 1. Do you see an alternating series here, guys? Does this one converge? Does this one converge? Yeah?
Yeah.
Yeah, it converges. Right, if you plug in 3, what do you get? You get 3 take away 2 to the power of n over n to the 4 plus 1. That becomes 1 to the power of n over n to the 4 plus 1. But isn't 1 to the power of everything just 1? Do you see a p-series? Or at least a limit comparison test to a p-series? Will that converge?
Yes.
Yes, isn't it equivalent to a p-series 4? So what we now know is that the interval convergence uses both the endpoints. So as long as you pick a value of x between 1 and 3, including 1 and including 3, this power series, this Taylor series, will converge to something. Is it pretty similar to the Maclaurin's one, you know, the method? So you can do A, you can do B, I mean, you can do both, depending on the context. Okay, let's find another guy. Let's go ugly. Oh God, this is ugly. Good, I like ugly. They're challenges. This is a limit. It's going to be n equals 1 to 8, the square root of n, x plus 5 to the n, and on the bottom, 8 to the n. Right, you agree that's pretty ugly, isn't it? Pretty messy. Let's see what we get here. It's going to be the limit as n tends to infinity, the ratio test. So I'm going to get the square root of n plus 1, x plus 5 to the power of n plus 1, all over 8 to the n plus 1. And then I turn it upside down. And I get that. Okay. Any cancelling? Tell me what I can cancel.
You can get an x plus 5 in the top.
Great. Anything else?
The 8n plus 1 will become the a, and the a will disappear.
And will there be an 8 left over somewhere?
Yes, in the denominator.
Gotcha. So we're going to have an x plus 5 here. We're going to have an 8. Okay, so the two pieces that are left over look like that, right? I like taking care of the n's and the n cubes separately. Now, what will these guys be? What will the limit of those two square roots, n plus 1 on the top and n on the bottom, get you?
1.
1. Right, you want to prove that? I'll put it in a little bubble over here. One way of doing this would be, couldn't you put it inside the square root? And then do that, and then couldn't you brute force it? And wouldn't that be square root of 1 plus 1 over infinity, square root of 1 plus 0, square root of 1, 1. Which means that we can now go to x plus 5 over 8. So that's what the limit ends up being. Have you detected a pattern here that polynomials and square roots tend to just end up being 1 when you're finished, right? You notice that n cubes get you n cubes and n plus 1 cubes get you 1. You know, n square root n's get you 1. That's pretty common, right? So don't be surprised when that happens. Now, this is the limit. If it's going to converge, the ratio test says that the limit must be less than 1. But that's not the form that we need. What do you think I'm going to do to both sides to get it into the format that we need to get radius and interval of convergence?
Multiply by 8.
Yeah, agreed? So I now know that the radius of convergence is 8, and the interval of convergence I'm going to solve by converting into that. Then in this case, I'm going to take away 5 from both sides. 5. There we go. Taking away 5 from both sides. And so our interval of convergence at least is going to start life like that. And that means I need to check the two endpoints, negative 13 and then 3. If you do negative 13, you get sigma square root of n. Negative 13, add 5 to the power of n over 8 to the n. That's going to be negative 8 to the n over 8 to the n. Since I don't have much room, can I just tell you it's that? Do you see an alternating series that diverges? Basically, the 8's cancel and you're left with a negative 1 to the n. That's a big D. If you go the other way, you're going to have 3 plus 5 to the n over 8 to the n. That's going to be 8 to the n over 8 to the n. And that is another diverger. So our interval of convergence is in fact this one. You cannot use either endpoint. Short little break. I'll tell you some history. Maclaurin series, right, the guys that looked like this, named after a very famous Scottish mathematician called, not surprisingly, Maclaurin. He was a very exceptional mathematician, right? One of his sort of notes of fame is that he was extremely young. Now, you know today that you sometimes see on the TV somebody who goes to university at 14, you know, and then graduates at 17 and so on, you know, their first degree and then so on and so forth. But in the times that we're talking, right, in the 1700s, the vast majority of the entire population couldn't even read, right? So the education level was very low. And he actually, for many hundreds of years, had the world record for the youngest professor who taught as a full professor at a university. And just because I'm arrogant, He taught at my university, Glasgow University. He wasn't, unfortunately, a student at my university. One of those other Scottish universities got him, but we'll not talk about that. He became a full professor. And you've got to remember how you become a full professor, right? You have to get your first degree. And then it takes you about 2 or 3 years, typically 3 years to get your PhD. You then have to go to a university to accept you to teach, and you have to become an associate professor, which can take 3, 4, 5 years. And then you become a full professor. And he became a full professor when he was 19 years old. And he started university at 14, but he didn't take 4 years to get his degree. Like he got his degrees, like Sheldon, right? He got his degree in a year, right? And then he got his PhD 2 years later, and off he went. He would have been a professor a lot longer if they didn't have, you had to do 3 years as an associate before you could become a professional, right? A full professor, right? If they could have, he probably would have been one when he was 16. So can you imagine that you could be at university and the guy in front of you is like 4 years younger than you, right? That would be kind of cool. I would have loved to be around it those days. And he finally got beat, and he's probably been beaten, for the world record. And he was beaten by an American girl who became a full professor, mathematics professor at a university in Taiwan. And I wish I could tell you her name, but I can't remember her name. But isn't that kind of cool? That way back there, in a time that was a lot harder to do what he did, right? Today, young proteges do appear. On that same note, since I'm in a blethering note, a few years back now, over 10 years ago, I was teaching a night class, calculus class, and I had a 14-year-old student doing Calc 1. He was homeschooled, and he got to the point where his mum couldn't do any more math. So he had to go to college because that was the only place he could, get the advanced classes. And he was a real cool kid. He was as sharp as a penny. You lot are in general, all of you probably, sharper than I am. You are probably more intelligent than I am, for sure. But the reason I'm teaching you and you're not teaching me is that I've got one thing called experience, which is I've been teaching for 40 years. So you don't get that overnight. And so that's it. And so I've seen many more equations than you, right? I've factored many more things than you. And that's the only reason I'm better at it. It's not that I'm cleverer than you. So don't think that. But he was such a sharp cookie. I just loved it. He would find ways of doing things that I never thought of, or shortcuts. And I thought, God, that was cool. I liked the way you did that. Right? He just did things differently. And anyway, the bottom line of the story before we carry on is that, I was saying, what's it like, because it must be quite hard being that kind of kid. Can you imagine their life, well, he never went to high school, thank goodness. Can you imagine the bullying he probably would have got, And I don't even think in America they let you do that. Do they let you, if you're 14, take senior classes? Be hard anyway, so he never did that.
Yeah,
And
you can.
You can, right? But
Yeah, the running start rules are different. I think you have to be 15 to do running start.
right, well, evidently his mum had clout, so you get in earlier. But I guess if you're homeschooled, you can do anything you like as long as you pay for the class, right? So I went and talked to him, and chatting to him, saying, "What's it like?" And he says it's okay. He's fine. He does kid things, right? Play sports and does that. And anyway, it got round to the fact he had. I said, you're very intelligent for your age. He says, I'm not that intelligent. He says, should see my sister. She's 12. She's much more intelligent than I am. I thought, oh God, no, there's another one of you. So it's just. My job is so much fun at times. Some people, I guess, don't like intelligent people. I love intelligent people. I like people that be more intelligent than me because it's so interesting to see how their brain works. So I'm going to try and make your brain hurt by this one. First question, why did this power series, this Maclaurin series, why does it start at 4? Why? Well, let's ask it differently. Why didn't it start at 0 or 1? Okay, why didn't it start at 0? There's very specific. What's the problem with n equals 0?
You're dividing by 0.
Right, and isn't the log of 0 not a good idea as well? So does it affect anything? No. Aren't we going to do the exact same test, the exact same conclusions, the same R and the same interval of convergence? So for all intents and purposes, couldn't you just not bother looking at that and it wouldn't change anything? So don't get distracted if it's not starting at 0 or 1, right? Because some of them don't. Now, if we do the limit as n tends to infinity, the reason I picked this one was because of the log. It's going to be the natural log of n plus 1, x minus 1 to the power of n plus 1, all over 4 lots of n plus 1. And then if you turn it upside down, you get 4n. You get the natural log of n, and you get an x minus 1 to the power of n. And I'm doing the next bit. The usual cancel. And what's left is an x plus 1 on the top. And I'm going to put similar things above each other. That's normally a good idea when you're trying to do a complicated limit, is to put like with like. Oops, that's a minus 1. Right. Let's focus on this guy. Would you agree that the limit of that is 1? And couldn't you prove it? Divide top and bottom by n or L'Hopital. So are you comfortable that that's a 1? And this is still x minus 1. So here's the new guy in town. The reason I picked this question. That one. What is the, well, let's phrase it a different way. How can you prove to me that the limit is 1? Because it is 1.
Can't you break up the top into natural log of n times the natural log of 1?
No. It's the other way around. Products become adds, not adds become products.
Oh, I always get them mixed up.
No, well, it's fine. You're allowed to. You're thinking. Thinking is good. Right, there's your problem. Tell me a method. To me, anyway, there's only one. There's only one way that's really possible to prove that this is 1. Would you agree you can't divide the top and bottom by n, right? That ain't going to work, right? That's just, it's not the right shape for that. But there is another guy that we've got, isn't there?
L'Hopital?
Yes. Now you're going to say, wait a minute, I don't see that happening. Let's give it a chance and show you how L'Hopital can work. If you differentiate the natural log of n plus 1, don't you get 1 over n plus 1? Great. And if you differentiate the log of n, don't you get 1 over n? Now, doesn't this ugly fraction divided by another ugly fraction become 1 over n plus 1 times n over 1, which means it now becomes n over n plus 1. Can we find the limit of n over n plus 1? Yes, can we just do L'Hopital again, since we're in the L'Hopital theme? And if you did L'Hopital, isn't it going to be 1 over 1, 1? And like I was saying earlier, I know how to do that, not because I'm, a genius and I create things from scratch. I do that because I'm sure, although I can't remember, the first time I looked at that, I was scratching my head thinking, how on earth am I going to do that? And then I tried a couple of things and finally I tried something and it worked. And then it stuck in my head. So if I ever see a log over a log again, L'Hopital got me out of trouble, right? And so you just add it to your list through experience, right? Now that you've seen that one, hasn't that now been joined to your experience list? I now know how to do log of this guy divided by log of that guy, right? Well, you put this package together and you get that. And of course, as we did before, the limit needs to be less than 1 if it's going to converge. And that gives me a radius of convergence of 1. Anybody want to try the next guy in their head? What would that become as an interval?
0 to 2.
Looks good to me. You agree that's how it starts, and you add 1 to each side? So far, so good? Now, like every other situation, don't we have to check the 2 endpoints? So the 2 endpoints are, I'm going to find out what happens at x equals 0, and I'm going to find out what happens at x equals 2. At x equals 0, it's going to be the natural log of n, 0 take away 1 to the n over 4n. That becomes -1 to the n log n over 4 to the n. Do you recognize an alternating series test? Agreed? Alternating series test. Is that one going to converge or not? What's your gut feeling?
Converge.
It is. We'll assume that it's decreasing, which it is. Would you agree that the 4n kills the log? In other words, the limit is 0, and that's all you need. So I know it's going to converge. Now, if you do x equals 2, you get the natural log of n. You get 2 take away 1 to the n over 4n, and that becomes, well, 1 to the n you don't worry about, it's just 1. You get that. Does that converge or diverge? A log over 4n. Converge or diverge? What's your gut feeling?
Diverges.
Yes. Let's prove it to you. Would you agree that that guy is greater than or equal to that guy? So I'm going to do a comparison test. Agreed? Remember, comparison tests are used when there's weird stuff, right? Would you agree log is one of the weird stuff, right? Now, what do you know about 1 over 4n? Well, if you want to write it down slightly differently, isn't it that guy? So isn't it a p series p equals 1, it diverges? And that's why Matthew, is that what you're thinking in your brain? Something along those lines? Right. So you put that package together and you can use 0, but you can't use 2. So the correct interval of convergence is square bracket 0, curve bracket 2.
I have a quick question.
Yes, Dylan.
Why are we using, why aren't we doing subtraction and addition anymore in the X? What changed to make us use this? I'm just curious.
I'm not sure what you mean by addition and subtraction, Dylan. But
So
what
in
you getting
the
at?
X minus 1
Uh-huh.
is greater than, less than 1.
Yeah.
The step below it.
Here?
Yeah.
How did you get from here to here? Is that what you're asking?
Like the other test, I guess, that we were using didn't use it, and I'm curious what the difference is.
Okay, so if I pick up correctly, in Maclaurin series, you end up with things that look like that. And if you want to solve when is the absolute value of an x less than 3, that transfers to that guy. So I didn't need to do any add and subtract. If, however, you've got the absolute value of, say, x take away 2, say less than 1, then the transfer you get looks like that. You see the 1 generates the outsides. Now, what I do here is I simply just add 2 to all sides. So that's why the adding is happening. And the reason I'm wanting to add 2 is I want x in the middle. Of course, if you get an x plus 5, like this, then the absolute value equation or an equation gets translated into this situation. So if the absolute value of x plus 5 is less than 1, that means that x plus 5 has to be between 1 and -1, right? That's what makes its absolute value work. Now, in this case, won't you subtract 5 to everybody? And that gets you -6 and x in the middle and -4, because we want, in every case, to know the range of x's, right? What does x start and finish at? So here it's between -3 and 3, here it's off center, here it's off center.
Gotcha. Thank you.
Okay, right, let's go. Last name and bye-bye. I'll hang about for any questions. We have learnt some cool stuff today, including that I'm not that intelligent. I think you probably knew that anyway. Although I'm probably more intelligent than average, if I'm being generous. As soon as you said bye-bye, I'll hang about if you have any questions.
So, on question 6 of the online test 3,
Yes,
it's should I like read out the question to you, or?
sure, if it's quick, go for it.
Okay, it's the, I guess, the summation from n equals 0 to infinity of -1 to the n over 9 to the n, then n like exclamation point or like factorial.
In factorial, on the bottom?
Yeah, on the bottom.
Okay.
And the only issue I had with it is at the bottom it says, if the series is convergent, use the alternating series estimation theorem to determine how many terms we need in order to like find the error less than 0 point, then there's 5 zeros and a 5.
Okay, so you wanted it to be 5 decimal places, right? I'm assuming.
And I just wasn't sure how to do like the math and stuff.
Ah, right,
I know
yeah,
the
I got
general-
you. So what you would do is you want this term to be equal to 0.1, 2, 3, 4, 5, and then you finish with a 5, right? So if it's 4 decimal places, you do 4 zeros and a 5. So,
Yeah, I get that.
right. So what you don't need to worry about the one thing. What you're trying to solve here is that problem, right?
Yeah.
And the answer to this is maybe not very satisfying, is that you cannot solve every equation, and that's really just an ugly equation, algebraically. Some you just have to do by, for want of a better word, trial and error or guess and check. So what you would do is you'd try n equals 4, n equals 5, n equals 6, and you would get the value of this. And well, when you do it on the calculator, you probably want to realize that this is going to be that guy in scientific notation, right? So I would go to my calculator, and which one of those numbers do you want me to try? 4, 5, or 6?
I suppose 4.
4. So you would go 1 divided by, put a bracket around it for safety, n to the power of 5 times 5 factorial. And so there's a 5, math button, down to choice number 4. And finish our bracket, and hopefully it works. Do you see that that guy is essentially 1 e to the -7? Isn't that in fact more accurate than it needs to be? So,
Yeah.
so my next guess is going to be 3. And so I just go and I try this, and I'll try 3, which gives me 4 here and 4 here. And the answer I get this time is what? 6e to -6. Ooh, almost made it. Agreed?
Yeah.
So I'm pretty sure I don't need to check the next one, but won't n equal 2, sorry, went the wrong direction here. Since that one almost made it, would you agree that I need to go up and which means I need to do 4, even although that's an overkill. Because
That's
n
what I-
equals,
That's what I put as my answer though. Like I did, like I
Oh.
figured that I probably had it tested and I still got it wrong.
oh,